Hello. Hello. Sir. Hello. Sir, it is not audible. Sir, are you there?
లేరు బ్రో సార్.
Presentation on అయ్యింది.
సార్ నంబర్ ఉంటే కాల్ చేయండి ఎవరైనా.
హలో సార్. సార్ క్లాస్ స్టార్ట్ అయిందా సార్? క్లాస్ బిగినింగ్ దగ్గర నుంచి చూస్తున్నాను సార్.
Is my voice is audible now?
ఎస్ సార్.
Now my voice is audible?
ఎస్ సార్.
Yeah. I think I'll start from here again. Maybe the technical issue we are facing. Not a problem. I'm going back and I will explain once again what I have been explained very quickly. Even I'll start recording over here. Yeah, it just started recording. Okay, however. Yeah, now my voice is audible for everybody.
ఎస్ సార్.
Yeah, we were discussing about the SFD and BMD, which is one of the important topic for the gate point of view from the strength of material. We have already discussed so many topics like simple stresses and strains, like complex stresses. Even we have seen shear stresses, shear strains. Even we have seen like how to form the principal stresses like sigma xx, and what is the stress tensor we have been discussed in the previous classes. And today we are going to discuss about the shear force diagrams and bending moment diagrams, and what are the tips to crack the SFD and BMD in the gate examinations, especially when you are experiencing these kind of questions for the both civil and mechanical students. So what is meant by beam here? If you see, it is a member subjected to transverse loading. Like if you see here, there is a coordinate system, that is x and y and z coordinate system is there. In the x and y coordinate system, when you apply the load along the y direction and z direction, then only it is a transverse load. Due to transverse load only on the beam, the bending moment may develop. Okay, whereas if you apply the load along the x direction, so that may be a axial load. It may not be a transverse load actually. Admitted, no, madam. Madam, you have joined, madam Lakshmi Keshav, madam. I have admitted you. For the students, no issue, no. It is understanding for the students. Please respond, someone.
Yes, sir.
Yeah, here the transverse load may be a water force from the bottom for the wooden log. When any wooden body or boat or steamers and all, it is floating on the water. So from down, whatever the force we are getting under the upward pressure, so that is also maybe a transverse load. We should not assume only beam should rest on some supports and then only we will call it as a beam. It is not like that. Any body is floating on the water also will experience the transverse load like this, which I am shown here. That is a wooden log. And even another example is cricket bat hitting a ball. Cricket bat hitting a ball, when ball is hitting on the bat, so that force is also a transverse force or transverse load. And next one is types of supports. We have roller supports. So roller supports can be represented like this: triangle with two small circles at the bottom and one circle, and at the bottom we can show like this hinge kind of symbols. And vertically also you have a like roller can be shown like this. But if you see this kind of guided kind of roller, and this can resistance to translation is achieved only in axial direction of the support. Okay, vertically you will not get any translation, whereas horizontal only you have a translation. But beside of these two, it has vertically only translation, horizontally it doesn't have any control. Actually it doesn't have any resistance along the horizontal. For the last one, it has horizontally resistance is there, vertically there is no control. And second one is hinged or pinned support. So that can be shown like this. It has two unknowns or restraints. According to me, the another language of understanding of about these arrows are restraints. And this is also one kind of hinge support can be shown like this. And this also has vertical and horizontal unknowns or restraints. Then another one, the third one is fixed support. Fixed support has three unknowns. Those are one vertical, horizontal, and along the z direction. Maybe it depends on support condition at the right hand support, sorry, left hand support and right hand support. Your bending movement direction may change, but here it is showing as a anti-clockwise movement. And fourth one is inclined roller. So inclined roller will be creating with the some angle theta, and it will generate the some inclined force, and this inclined force R can be rotated either horizontal and vertical. You can resolve horizontal and vertical to calculate the unknowns at the inclined support. It looks like roller, but it's behave like hinge actually. And another fifth one is guided roller. It's a guided roller. Actually, it can resist vertical load and movement. Actually, you can see this. It's a guided roller actually. This is also one of the type of support. Then another one is types of beams. So in the types of beams, if you see here, in the types of beams, if you see here, out of these four type of beams, which is accepted, means last one is only accepted because you supposed to show one side is hinged and other side is roller. Even in the note also you can read very thoroughly. In simply supported beam, one end should be hinge and other should be roller in order to resist any horizontal load and for no thermal stress to develop. Okay. Then cantilever beam is one side only fixed and other side is free, and you have a C. Third one is fixed beam. Both sides are fixed, and property cantilever is one side is fixed and other side is roller or hinged. And fifth one is continuous beam. You have more than one span, that is nothing but a continuous beam. And overhang, there are two types again, single overhang and double overhang. If you have only one side overhang, that is single, and if you have two sides overhang, that is double. Beam with internal hinge, there is a best example to understanding about the internal hinge, that is fixed support at centrally there is an internal hinge. Due to this one, the bending moment at internal hinge would be 0. Okay. Then if you better understanding about the what is meant by determinacy of beam, there are two types of determinacies. One is determinate beam and indeterminate beam. In determinate beam, conditions of equilibriums are sufficient to determine the support reactions. What are those? Summation of Fx equals to 0, summation of Fy equals to 0, and summation of moment at any point equals to 0. Those are the equation of equilibriums. Those are sufficient to analyze this kind of beams actually. And no additional compatibility condition is required for this type of beams. Degree of indeterminacy DOI equals to R minus S, where R equals to number of support reaction, S is equals to number of equilibrium equation. And indeterminate beam, conditions of equilibrium are not sufficient to determine the support reaction. Compatibility conditions are required. Compatibility conditions are required. And DOI equals to 0, so there is nothing but a indeterminate beam. Whereas DOI greater than 0, it is a indeterminate beam. This is, I think you already knows, but better when I am explaining everything step by step procedure, I have included this. Then you can see the different type of examples to find out the which is the determinate and indeterminate with the different type of support conditions. Like first one is simply supported with one side hinge and another side is roller. So unknown reactions are, yeah, madam. Hello. Yeah, 1 minute. 1 minute. Excuse me. Tell me, madam. One minute for madam, she wanted to join. 1 minute. Yeah, joined. Yeah. So you can cross check here for distinguish between the determinate and indeterminate beams. And starting from number 1, you have a simply supported, one side is hinged and another side is roller, and you have a 3 unknown reactions are there here, and the formula is R minus S. So that is nothing but a R minus 3, and 3 minus 3 you are getting it is as a 0. So it is a determinate beam. Then second one is two sides fixed supports are there, and you have a 3 at each support, and altogether 6 minus 3, it is getting 3. That means you need 3 more extra equations, those you may get from compatibility conditions. So third one is you have a cantilever beam, that is DOI is 3 minus 3 only, that is 0. So that means the cantilever beam is also statically determinate structure. And comes to the fourth one, that is proper cantilever. One side is fixed and another side is roller. Altogether here you have a 4 unknowns, that is 4 minus 3, you are getting 1. So you need 1 more extra compatibility condition. Then fifth one is continuous beam. One side is hinge at the end, at one end, and another end is roller, and intermediate support you have a roller. So all together you have 4 unknowns, that is 4 minus 3 equals to 1. And the sixth one is two sides overhangs are there, but you have a one hinge and another roller. But if I keep two rollers, what will happen? It may not be stable actually. It is unstable. If you try to apply some load, it will not be there. So it will keep on moves. It will move, keeps. So this kind of case actually it never exists in the practical. So that means two rollers condition, it never be there, and it's a purely unstable condition. And if you keep two hinges, and again it will become a statically indeterminate structure. Then seventh one is you have fixed support with internal hinge. Due to this internal hinge, as I already told, one additional equation may develop in addition to summation of fx and summation of fy and summation of m. You have to apply one more equation to resolve this kind of beams. So that is why 6 minus 3 plus 1 it is getting added here, and finally it is unknowns are 2. Remaining unknowns are 2 actually. So for this 2 you need 2 more equations to analyze or to know these unknown reactions. And the load may be a general loading or inclined loading. And in strength of materials, SFT and BMD are studied only for determinate structures only, because in structural analysis generally we are going to discuss about the indeterminate structures analysis. And here if you see the types of loading, for better understanding of the different types of loadings acting on the structural components such as beams or columns or slabs, but what are the different types of loading systems? If you observe here, it may be clumsy, but we can understand it very easily. The P kilonewtons point load, this will act at only one point actually. And uniformly distributed load means it will act along the some span of length. And if you want to convert this into equivalent point load at the center of the span, you can calculate by doing the total load equals to area under load intensity diagram, that is W into L. So you may convert that is into a equivalent load, and it is now become a point load like earlier one which I have shown here. And another one is uniformly varying load. For the uniformly varying load also you may calculate the equivalent point load which is acting as per centroid of that shape. For triangle, area is half into B into H. For parabola, that means triangle means linear variation, uniformly distributed variation means according to me it's a 1 degree variation. If you talk about the parabola, it's a 2 degree variation. If you talk about the cubic parabola, it is a 3 degree variation. Say you have a load of linear variation that looks like a typical triangle, then you have centroids 1/3 and 2/3. From where 1/3, from where 2/3, that is you know from the basics. And if it is a parabola, your centroidal distances may vary from 3/4 and 1/4. Okay, then if it is a cubic parabola, your loading variation will your centroidal variations will be 3/8 and 5/8. So this is you know from the basics. Just the situation has been demanded, that is why I am giving orally how to locate the centroid for the different shapes of the geometrical things. And say you have a uniformly varying load, but it is looking like a triangle. For this, if you want to convert a equivalent load, that is W, we can calculate half into B into H. What is B? L. H is what? W. So finally you get WL/2 is nothing but your equivalent load. Now onwards, that load will act as a 1 point load, but the applicable distances. Then you can easily calculate the whatever you want, like shear force and bending moment, or if you want to calculate the reactions, RA and RB for the simply supported beam can be calculated. Any type of load can be applied on the beams in the practical applications. So you can simulate the type of loadings which we are discussing in the classroom now or in the class discussion to the practical simulation. Then you have a concentrated movement, that is M. It may be a clockwise or it may be anti-clockwise, but it will act at only at one point. That is why we used to call it as a concentrated movement. And this couple, how it is acting with heights of A and A, but it is acting, both are acting in the opposite direction. It will develop it as a one couple, anti-clockwise couple. For suppose if I apply this arrow on this side and this arrow this side, automatically it will generate as a clockwise couple. So what is the value of this one also can be seen here. Then there is another category of loading, that is uniformly distributed movement. So that means on the entire span, up to some span, you are going to distributing the only movement meter. Okay, it is not kilonewton per meter, it is already kilonewton meter per meter. So like that, the uniformly distributed movement may look like. Then uniformly varying movement, it is similar to the uniformly distributed load only, but here it is movement, it is a load. For load, units are kilonewton per meter. Here bending moment units are kilonewton meter. So that is already you knows that. And now come down the how to determination of the support reactions by applying the equation of equilibriums. Okay, when you are finding that there should be a one fixed or assumed sign convention, once you take that one, you try to take up to end of the your course or up to end of your practice, and enter your wherever you want to use, you try to use this sign convention only. Please do not confuse with sign conventions. Sign convention is only a part of the concept, but your main thing is that main soup, the content, the concept you supposed to understand, where the bending moment is getting 0, why it is getting 0, why bending moment is not there, and where shear force gets 0. These are all things you supposed to observe rather than worrying about the sign conventions. You should not worry about the what is the integration of x. You must have that is in your mind as a fingertips. What is meant by cos sin theta, opposite side by hypotenuse, and what is cos theta, adjacent side by hypotenuse. You should not remember these all things in this stage actually. Okay, these are only supporting things for better understanding about these mechanics. These are basically mechanics to do the analysis for the structures. Based on this basics only, from here only the whole design, what are the buildings you are seeing in Vijayawada. If you talk about the like iconic buildings like Novotel Hotel, like different big buildings are there. Those all are designing based on these concepts only, from starting from basics. And in this, if you see the one simply supported beam having A, B, C at center C, and applying load at the center P, and at hinge support obviously you have a horizontal reaction and vertical reaction, VA and HA, and at B only you have VB actually. And as per your equation of equilibriums, summation of all horizontal forces are equals to 0. Unless until you are not making it to 0, how equilibrium condition may satisfy here? That means you are assuming that all forces are going to be 0, means then only what are the unknowns are there in this side of LHS, then only this will come, unless until you will make into 0. You are not making into 0, and what will happen? You can't find the unknowns actually. And that too, this is all about statics only. Why I am talking about statics? Summation of fx equals to 0 means it's static. Summation of fx equals to say m into ax. What is meant by m into ax? F equals to ma. What is the law? Newton's second law. It's a great law. So those expression will be applicable for the dynamics actually. Motions. Body is in motion. Body is not in rest. So it is not applicable to statics. It will applicable to dynamics. So kinematics and kinetics you have studied in the first year courses. Those always deals with the your summation of fx equals to mass into acceleration along the x direction. That is F equals to ma. But this is all about we are discussing statics. That is why summation of fx equals to 0. And here from LHS to RH, what are the forces are going horizontally? Those all you assume it is as a positive. and reverse way is negative. And this is the coordinate system, x coordinate and y coordinate system, x-axis and y-axis coordinate system you can observe here. Then second thing is from by applying this, your HA is becoming into 0. So that means there is no horizontal force. And now second equation of equilibrium is summation of Fy equals to 0, upward clockwise, upward positive, downward negative actually. So for that, if you apply that one and if you find out, you will be getting the expression is VA plus VB in the form of V and VB equals to P. That is say equation number 1. Now the final equation of equilibrium, you can apply anywhere summation of MA equals to 0 or summation of MB equals to 0. That is up to you. You can apply that. But here the sign convention is clockwise positive, anti-clockwise negative. So VA is clockwise to reach B, correct? To reach B, correct? Like this. I am talking about like this. Like this. Even I can take the marker, pen. Like this, correct? This one. Correct? Eraser. Okay. Yeah. So based on that, you can find out the VA, and obviously if you keep this VA in the first equation, you will get the VB. So both VA and VB, you are getting P by 2. And if you move to the second case, simply support with the UDL, then again how to find out the VA and VB can be seen here. And what is meant by anti-clockwise and what is meant by clockwise, you can see. And distance, what is meant by bending moment definition and shear force definition. Shear force is nothing but a algebraic sum of all vertical forces are equals to 0. Then bending moment means algebraic sum of all moments are equals to 0. What is movement? Bending moment definition: perpendicular distance, load into perpendicular distance, transverse load into perpendicular distance. So that is nothing but your anti-clockwise and clockwise movements actually. Then how to find out the reactions can be seen from here. And now if you move to the question number 3, uniformly varying load, but from starting point it's 0 and at the end point you have some W kilonewton per meter. Then how to find out your VA and VB by applying your regular equation of equilibriums. Obviously you will be achieving to getting the VA and VB values at the unknown places. Then fourth one, say you have a simply supported with concentrated movement, like one couple at the center is there. Then how to find out the VA and VB as it is by applying summation of Fx equals to 0, and again here it is getting HA equals to 0 and summation of Fy equals to 0 and VA plus VB equals to 0. Therefore VA equals to minus VB. That means summation of MB equals to 0. So VB equals to minus VA. That means VB equals to M by L. How it has come? VA into L, and directly M is a clockwise movement. You put the plus M, and VA is becoming minus M by L. So reaction at A will be vertically down actually. That is why it is minus. Reaction at A, the movement will be downward. That is why this minus is coming. Whereas VB is already minus is there here. The minus will become plus. For VB, your movement reaction will be upward, okay, not downward. So this is all about when you have the concentrated movement at the center, at the distance of L by 2 from each support. Then next one is, say you have a varying load, varying distance load. Varying distance load means it is not acting at the exactly L by 2 distance. It is acting at the from A distance, small a distance, from B, small b distance. So likewise, if you have how to find out the VA, VB can be seen by applying the equation of equilibriums from step-by-step procedure here. Then you may experience this kind of questions also, that is bracket. Say height of the bracket is 2 meter and width of the bracket along the x-axis is 1 meter. At the tip of the bracket you have some load of 10 kilonewtons. Then how to solve this problem you can see by drawing the free body diagram. So these are the tricky problems. These type of problems only you may experience in the examination. Okay, obviously, actually, whatever we have said, the 10 into 1 meter is nothing but your movement will be there. This one horizontal distance only have to take. Then only this will become at C point as a movement. Okay, as a movement. Then by applying that one concentrated movement, then you start doing the work, and how to do the all calculations can be seen from step-by-step procedure, and finally how to find out the VA/VB from the given problem can be seen here. Even this one is anti-clockwise. It may be opposite couple or opposite movement actually. Even you can see this how to show the couple and movement. Question number 7. Yeah, this kind of problem is also possible because the load is not acting at the tip of the bracket vertically. It is acting at the tip only, but horizontally it is acting. Then how to convert the load into your movement? So here, which is already 10 kilometers are there. There will be one horizontal load here, and again this 10 kilometer into what is your transverse distance, like lateral distance, 2 meter actually. So 10 into 2 meters will become again one anti-clockwise couple over here. But here when you are calculating the HA plus 10 equals to 0, here you are getting HA equals to minus 10. That means the HA will act in the left direction. Oppositely HA will be acting. And how to calculate this clockwise couple moment can be seen here, which you already placed with the red color. And after applying the summation of Fy, and finally how to find out the VA. And in the VA minus 5 kilonewtons, so VA will acting downward direction. Okay, because it is a couple actually, clockwise couple. And there is a cantilever beam. For cantilever beam, how to find out the your bending moment, and even VA, HA, how to find out, you can easily observe here from the step-by-step procedure. And again, cantilever beam with UDL, how to find out the bending moment. That means unknowns are there, VA, MA and HA, how to find out, you can see in here. And cantilever with uniformly varying load, but at this fixed support you have a maximum magnitude, whereas at the free end we have a 0 magnitude of that uniformly varying load. For that, how to find out the your reaction on the unknowns VA and HA and MA can be seen from this step-by-step procedure of this document. If it is okay, I'll go to the another level. Please, anyone, please respond. Any student, are you able to understanding what I'm explaining you? Please respond. Any girl student? Any girl students are there? Please respond, Andy.
Yes, sir.
All students.
Yes, sir.
Yeah, these are very good collection. I'm telling you. If you have this already, of course, one information for you. I already forwarded the PPT, prepared PPT, starting from day 1 class. In that PPT, the syllabus of GATE, changes in GATE, and even what is the strategies to prepare for the GATE examination, even from starting class onwards, like simple stress and strains, everything is there with the cam scan photo snaps of my prepared running notes with my writing. You can have that, and you can practice that and try to prepare yourself with your own documentation, so that you will be very strong in the basic concepts. See, in the GATE examination, by heart or batti kottadam, ivanni nadavandi, only concept. Unless until you are not having concept, you can't crack the questions. Sometimes the all answers may look like same. Only talent and your concept only will help here. Otherwise, if you want to keep in the flukes, flukes will not success. It will leads to negative marking unnecessarily what you were supposed to get qualified. That is also you will miss sometime. See, up to some 20 questions or 30 some 20 questions you attempted very carefully, the reduction or negative marking percentage was very less. Say afterwards what happened, you thought that everything is I'm achieving and my exam is going well, let me attempt few more questions. Like that, if you started showing so greediness, it may leads negative marking sometimes. What is my strategy to apt the correct answer is, for us generally how many directions are there? 4 directions: east, west, north, south. From these 4 directions, if you feel this answer is correct, that means 4 sides it should satisfy that answer is correct, then only you select that answer, then only it will going to be correct. Otherwise, if any small doubt is there or suspicion is there, okay, anticipation, please avoid this. Anticipated, suspicion, this and all avoid. Only cross checking, direct concept or direct empirical formulas are okay. Sometimes you wanted to apply some concept and you have to do some mechanism, and finally you got something. While applying this mechanism on your rough papers, you committed the mistake that you don't know, because that stipulated time 3 hours, you will be in very pressurized condition. The situation is totally different from the regular situation. So that is why, to overcome that situation, you must be well practiced. You must be thoroughly ready and go for the examination. That is only possible when you take this material from the faculty members regularly with prescribed schedules. If you plan, then only you can achieve this gate. Even if you are not sincere, I am telling you, no other circumstances like reservation or some etc will not help you. And I am telling you, this will applicable for not only you, entire India, because the gate examination is going to be there for the entire India. And that too, this time, as I already told in the initial classes, it is going to be big competition in this year. They are allowing third year students also. Okay. So with this, how to find out the unknown things at the support, you can see in for the uniformly varying load also. And uniformly varying load can be interchanged. At fixed support you have a 0, and at the free end you have a maximum. So that time how it is, little bit changes are there in the calculating MA and VA, because it is changing the distance, no, 1/3 and 2/3 it is getting changing. That is the reason. And you have another simply support, cantilever with at end movement, anti-clockwise movement. So that time how to find out the your VA, HA, MA can be seen here. Here HA, VA both are zeros only, because there is no load on the member, but at the end only there is a movement. Even in between, if it is acting at the one point as a constant movement also, then you must consider that movement while taking the summation of M at any point equals to 0. That is one of the equation of equilibrium. And shortcuts for finding the support reactions are generally the symmetry. If you see here, half of the load, so then half of the load means it will automatically share the half of that only. So P/2, P/2. And here also you have a W into L, then only it will become a P, correct? Otherwise capital W. Then again half of, if you want to distribute, WL/2, WL/2. So here WL is capital W. So capital W/2 also you can say, but you must write there capital W equals to small w into L. Okay. Then another second one is concentrated movement. Concentrated movement. So the concentrated movement can be seen here, like how to calculate shortcutly. Total M divided by L only, because it is acting along the whole L, and that is M by L only you can say. Okay. Otherwise, F into L. F into L equals to what? M only. Correct. So that is also can be say, but why downward and upward I already explained just before. And third one, if you see here, varying distance, the load is acting. When it is P is acting. If you're toward looking after towards at B reaction, that means VB reaction, your VB reaction will be PA by L only. It cannot be PB by L, because when you are looking after this side, your distance will be considered the another side of the distance of the load only. So that is PA by L and PBL, PB by L. How it has come, you can see here. And what is meant by superposition? Superposition is nothing but any type of load can be act on the beam. The effect of the any type of load will be same. That means if I apply simply support uniformly distributed load or even point load, the duty of the load is to give some stress on that particular member only. It will not do any other job actually. Okay, that is the rule of superposition. And here it can be seen how to convert this different type of loading system is there. How to convert this is into different type of beam beams. You can see here. This is equivalent to first one single simply supported with only UDL and plus only with point load, and the next one is only with the movement diagram. So if you add everything, all together, WL by 2 plus P by 2 plus M by L. This is for this side. And another side, if you want to calculate WL by 2 plus P by 2 minus M by L. Why? Because minus M by L is already, I told you, that is at the RA. This you are already seen. So that is the great understanding about superposition law. That is the superposition law. Next, the question number can be given like this, like one partially there is a uniformly distributed load, and at C point you have a point load, and from C to B you have a uniformly varying load, and somewhere at the one point there is a concentrated movement. Then how to apply these all things and how to calculate the bending moment can be seen here. You can see here by applying the first two equations. Before that, you have to convert this into free body diagram. How to convert this into free body diagram? You convert 3 into 2 is nothing but a 2 kilonewtons. It is acting exactly at the center of 2 meters. Then 10 kilonewtons as it is you take, and this one 6 actually it is there. And what is the span? Total 3 meters. So 3 meters means from here 2/3 L, 2/3 B. 2/3 B means 2 into 3, 6 by 3 is nothing but a 2 meters. That means the load will act from C is 2 meters. What is that magnitude? Half into B into H. H is 6 into 3, 18 divided by 2, 9. So you can see here 9 acting as a one equivalent point load from C at 2 meters distance. And as it is 20 kilometer meter can be taken directly because it is a concentrated movement. I hope you understood how to convert the free body diagram from the given member. Even it is been shown here, half into 6 into 3 equals to 9. Okay. Then from there, how to calculate the reactions also can be seen. If you know already the reaction formulas of the different categories of the members, you can easily calculate it. For suppose if you consider the first 6 kilonewtons, it is acting like a PB by L, no? PB by L. At VI is nothing but a PB by L plus. Then you take this one is also acting as a uniformly varying load, that is 10 kilonewton. For that also VA is what? PB by L. So like that you can take it. But when you're taking for 10 kilonewtons, what is A? A is 2 meters, B is 3 meters. For 6 kilonewtons, A is 1 meter, whereas B is 4 meters actually. Please do not confuse here what I am explaining. So likewise, if you know already all formulas and everything, so directly you can calculate the all values and all together you can add it straight away. And some people may confuse here. If they give this many loads and all, they may get a lot of panic to calculate the reactions. This is the shortcut method which I am explaining you. Take separate beams of one single load, and you know the already VA formulas for the different categories of the loading conditions of the so and so VA, VB, and add all together and finally write it a one single VA load at the and that particular support, and other side also as it is. And another one is question number 14 is a load of load intensity given by W equals to sine into 3 pi x by L. It is like a sinusoidal curve. Sine variation. No. What is meant by sine 0? 0 only. Sine 90 is what? 1. Sine 180 is what? Again 0. Sine 270 is what? -1. Sine 360 is what? 0. That means one complete cycle sinusoidal curve they used to call sinusoidal curve. It will come in the basically in the dynamics like vibrations, like a one complete cycle. Even how many of you heard about the cyclic loading? Cyclic loading is also based on the sinusoidal curve only. The great understanding of the sinusoidal curve is what is meant by sine 0. It's a 0 only. Sine 90 1 plus 1. Sine 180 semicircle and sine 180. It is a 0 again. Again another semicircle in the downward direction, it's a minus. Sine 270 -1. Again go back and meet to the origin point, that is your horizontal line point, origin point. That is nothing but your sine 360. Again it is a 0. So likewise the loading may be there on the beams in the side situations. It may be a cyclic load, or it may be some motorcycle load, bus load, maybe a like moving load. So these type of loads can be simulate. అంటే లోడ్ మనకు సైట్ లో పడుతుంది దాన్ని బట్టి మనం కన్వర్ట్ చేసి పేపర్ మీద పాయింట్ లోడ్ అని ఇదని. కానీ మీరు పాయింట్ లోడ్ అంటే ఒక యారో చూస్తారు, బట్ ఇఫ్ యూ రియల్లీ గో టు ద సైట్, హౌ దిస్ విల్ లుక్ లైక్? మేబీ సమ్ వాల్ ఆర్ మేబీ సమ్ మోటర్ దేర్, particularly at one place they are located. Otherwise one beam is resting on another beam. That means secondary beam is resting on main beam. So the main secondary beam load will act on the main beam as a point load, and that too secondary beam will act as a simply supported beam, not like a fixed beam in a building. In the interviews also, if anybody asks, when in the gate examination also, if anybody asks what is the in a building, in a residential building, how many types of beams are there, if they ask, straight away you will say continuous beams are there and fixed beams are there, but you will forget about the simply supported beams. In building, simply supported beams are also there. Sir, that means they are providing any rollers and hinges? No, they won't provide rollers and hinges. It will look like a rigid beam only, but it will act like a simply supported, because you are releasing the movements at the nearer to supports of that particular beam, because it is a secondary beam. It doesn't resting on supports, it is resting on another beam actually as a secondary beam. Okay, so that is, even secondary beam will create the torsion, that is secondary torsion. Okay, that is secondary torsion, and due to main beams, that is a primary torsion actually. In this kind of when it is load is there, how you will apply this is all together. L distance is there, and you have a expression of sine 3 pi x by L, it is there, and VA equals to VP only here direct, and half total load is what? L by 3 pi actually. Then when you apply your integration, obviously you will get like this, into L by 3 pi you will get like this, and finally when you insert these all values and everything, finally you are getting to L by 3 pi. So this is all about your VA and VB, how to find out the VA VB for this kind of loadings also. It is been showing here, and there is another simple description about the shear force and bending moment. Both shear force and bending moments are internal resistance developed due to externally applied transverse loading. Please understand what is meant by transverse loading and internal resistance developed due to externally applied transverse loading. SF at any section is the summation of all the transverse forces while moving left to right or right to left at that section. Okay, then here you can see how to do the free body diagram for when the forces are acting here like this. Okay, you can see they say there are P and P with distance of L, 3 by L, L by 3, L by 3, L by 3, like that if it is acting. Otherwise, all three single L's are there along the A and B beam. Wherever it is acting, those are like a C and D points are there. And if you cut the section XX from A, if you take the distance of X distance, if you form into, that is a free body diagram, obviously the reaction you have to show here, the distance is X, and when you cut here, there will be a shear force, correct? When you cut that, there will be a shear force, obviously. So the shear force can be shown here, and now to resist this one, the P will create the clockwise. This P will create the like this clockwise. This P will create clockwise movement, actually clockwise movement. To resist this clockwise movement, this one they put it, okay? They put this, okay? This is anti-clockwise movement, that is P into X, it is nothing but mx. And obviously here this side anti-clockwise there, and another side to resist that one, you should have a clockwise movement. And here there is a downward shear force, then obviously we will have a upward shear force to balance that. Okay, always balancing is the most important thing. And here the distance also, you know, this is L minus X and this is 2L minus X, and whereas this is 3L and 3L minus X. Please understand this. Of course, now when I am explaining at this moment, you may not understand it, but when you have this document which is already provided by me, please have a look. It is really helps you, and these are the concepts to help to crack the gate questions in the in the future, which you are going to attempt in the gate examination. Bending moment at a section is summation of all the moments caused due to the transverse forces or concentrated movement while moving left to right or right to left at that section. So mxx, right to left, if you see, that is can be taken like this: 3 into 3L minus X minus P into 2L minus X minus P into L minus X equals to 3PL minus 3PX minus 2PL. Like that, everything is getting cancelled. Finally, we are getting plus PX. It is a of course, clockwise or anti-clockwise, it doesn't matter. You can show that. Next, these are the important things. Points to draw SFD and BMD. Empirical relation between load intensity W, shear force V, and bending moment M is W equals to, first of all, if you ask me, I will say X equals to displacement, and otherwise deflection. Dx by dy, that means you are differentiating deflection with respect to y, you will get theta. Dx by dy is nothing but a theta. And again, you are differentiating the theta with respect to y, that is d theta by, I will write here. Say X is your deflection. If you are differentiating dx by dy like this, you are getting theta. This is slope. So d theta by dy equals to, you will get movement. If you are differentiating movement by dy, you will get V. dV by dy equals to, you will get W. Okay, dV by dy you will get W. And simultaneously now, if I differentiate dV by dy, what you will get? V. If I differentiate dm by dy, you will get m. If I differentiate d theta by dy, you will get theta. If I differentiate dx by dy, you will get x. That is the vice versa thing from differentiation to integration, sorry, this is integration symbol. From differentiation to integration, you'll go back to again deflection only. Deflection to load, how you are coming, and from load to deflection, how you are going. That is only the empirical empirical relations for the shear force and bending moments. You can see here minus indicates downward, nothing else actually. Do not confuse about that. W equals to minus dV by dx. The slope of the shear force diagram is equals to load intensity at that point. See, dV by dx is nothing but a slope of the shear force diagram is nothing but a load intensity. Then next, V equals to dm by dx. The slope of the bending moment diagram BMD is equal to the shear force at that point. Slope of the bending moment diagram. Next point, the point where load intensity changes its sign, shear force is either maximum or minimum. The point where load intensity changes its sign, shear force either maximum or minimum. Correct? You can see here for showing the load at C, load intensity changes its sign. So W is 0 here, and that is equals to minus dV by dx. So that is nothing but a dV by dx equals to 0. That means dV by dx is nothing but a W, no? So here W is 0 actually. V either maximum or minimum here. V, that means shear force. Next, the point where SFD changes its second point is the point where SFD changes its sign, bending moment is either maximum or minimum. That means V equals to 0, that is dm by dx equals to 0. So dm by dx equals to 0, that m is either maximum or minimum. Next, third point, the point where BMT changes its sign, bending moment is 0, and the point is referred to as a point of contraflexure. Okay, point of contraflexure. That means wherever shear force is 0, bending moment is maximum. Wherever bending moment changes sign, that is a point of contraflexure. Then third point, the point where concentrated point load is acting, there is sudden change in SFT, but no such change in absorbed in bending moment. Bending moment lo change avudandi, shear force lo change avutundi, ekkadaina oka load point load act avuta untayi. Next, third lone second point, the point where concentrated movement is acting, there is a sudden change in the bending moment, but no such change in absorbed in SFT. Vice versa ante. Concentrated load, concentrated movement. Okay, you can see this. This is one of the example how to do the. I can remove this. Okay. Yeah, this is the one of the example for better understanding about the how to start the shear force and bending moment. But you can see here it is being calculated VA and VB particularly. Now the things has been started at a first. Say there is a B, C, and D points are there. At D, just left of D, if you take this, the distances how it is cutting just left of the D, how the things are looking like 1 meter, 10 kilonewtons and 2 meters. So for that, how to find out the SF? D minus means left, D plus means right and D. Okay, D plus means right, D minus is left. Why I have written like this? For just understanding, quick understanding of the how to find out the shear force. Okay, even you can see here at B, SF just left of B, how much is there? How much is there? 4 kilonewtons. Bending moment just left of B, how much is there? 4 into 2 meters. Okay, this is one we are talking about. Then SF just right of B, not left of B, just right of B, how much it is there? 4 minus 10, that is nothing but a minus kilonewtons. And bending moment just right of B, how much? 4 into again 2 only, that is 8 kilonewton meter only. Then at D, if you see SF minus D, D minus means just left of the D, that is 4 minus 10, and bending moment just left of the D means that is D minus, that is 4 into 3 minus 10 into 1, nothing but a 2 km per meter. And just right of D, now just left of D gone, just right of D is nothing but a D plus అండి. మీరు అక్కడ కన్ఫ్యూజ్ అవ్వమాకండి, నేను ఇచ్చిన డాక్యుమెంట్ లో మీకు ఇది క్లియర్ గా అర్థమైపోవాలి. రైట్ టు లెఫ్ట్ ని చూపించడం కోసం ప్రతిసారి నేను డి రైట్ టు డి లెఫ్ట్ రాయలేను కాబట్టి ప్లస్ మైనస్ షార్ట్ కట్ లో వాడుతున్నాను ఇక్కడ. ప్లీజ్ ట్రై టు అండర్స్టాండ్ దట్. ఐ హోప్ హౌ టు క్యాలిక్యులేట్ ది ఎస్ఎఫ్ D plus and D bending moment D plus, that means the right sides can be seen here. Then the point where concentrated point is acting, shear force is not defined. It is defined in the RHS and LHS of the point load. The point where concentrated moment is acting, bending moment is not defined. It is defined in the RHS and LHS of the concentrated moment. And even if you see the load and SFD, how it will vary, and BMD, how it will vary, can be seen here. Even I wanted to make little bit zoom out for better viewing here. Say I have a load of no load, W0. What is SFD? 0 degree, straight line వస్తుంది అనమాట. W equals to dV by dx equals to 0 వచ్చేస్తుంది ఇక్కడ. V is constant, అంటే shear force is constant, nothing but a C actually. Then what about bending moment if no load? That is nothing but a straight line only, but it's a 1 degree. 1 degree means linear variation. V equals to dm by dx only. So if you are applying the integration for this, what you will get? What you will get here? One time dm by dx will become m when you are integrating with the dx. Then cx will become cx plus again integration constant c1 will come. Okay, cx plus c1 will come. Next, for suppose you have a UDL, W is constant throughout this entire the span. Your SFD itself single degree, that means linear variation straight line. W equals to, because of downward, minus dV by dx equals to 0. Sorry, it's a constant actually. Then when you are applying the integration here, what you will get? V equals to cx plus c1. Here itself you are getting expression actually. Then when it move to the bending moment actually 2 degree, I have not written here, 2 degree square parabola. So 2 degree square parabola is nothing but dm by dx equals to V is equals to cx plus 1. So already cx plus c1 is already there from here. Now if you apply the integration here, it will become m and it will become cx square by 2 plus c1x plus c2. Uniformly varying load means it is a 1 degree, the load itself 1 degree is there, and your SFD itself you will get the 2 degree square parabola, and W equals to minus dV by dx equals to cx. So if that is the case, you will be getting here V equals to cx square by 2 plus c1. This is a integration constant. So bending moment is 3 degree cubic parabola, dm by dx equals to V. So V already here it is there, cx square by 2 plus c1. From here if you apply the integration, it will become cx cube by 6 plus c1x plus c2. And what is the sign convention? Left to right and right to left. If you want to go, this should be followed. And left to right, if you want to go, upward force at left to right. If you are moving left to right means A to B you are moving in a beam. For suppose upward force is positive, downward force is negative. Bending moment is clockwise movement positive, anti-clockwise movement is negative when you are moving left to right. Okay, and when you are moving right to left, SFD upward negative, downward positive. Bending moment clockwise negative, anti-clockwise positive. And what is meant by critical point? These are points at which value of a shear force and bending moment should be known prior to the making of SFD and BMD. Okay, So I am reducing this. Now once again it can be make zoom out. The points are start and end of the beam. What are the critical points? Start and end of the beam. Start and end of an UDL or UVL. You must know this. Point where concentrated point load or concentrated movement is acting. Point where loading intensity and SFD changes its sign. ఎక్కడ లోడ్ చేంజ్ అవుతుంది, అదర్వైజ్ ఎస్ఎఫ్డి ఎక్కడ చేంజ్ అవుతుంది. Then you can start level 1 questions. Level 1 questions if you start here. What about your time? Shall I stop now? Shall we discuss in the next class? It is already over actually, 3.5. What do you say? Please respond, some of you. Respond avanandi. Some of you please respond. Some of you. Shall I stop now?
Yes, sir.
Yeah, because as per schedule actually I supposed to take only up to 3:30. I thought you may have another class. You don't have other class?
Next.
You have next class, some other class?
Sir, we are having
Which class andi?
engineering mechanics.
Okay, engineering mechanics. However, shall I stop now? Raghunath. Okay, then we will meet in the next week. Wherever I stopped it, I will resume from there. Be in the in time. Don't miss it. I hope you will be happy with the details which I am showing. Nowhere you will get. I am telling you, nowhere you will get these details. Maybe if you go and welcome the YouTubes and all, the people will explain you in different way and different style of explanation. But your way of understanding should be perfect, because if you are deviating from the different concepts and different way of teaching, it will be creating a lot of confusion to you, because you are in that level actually, because you are not cross these all levels and you don't know these all things. You may be new to these all things, but in your coursework time you might have studied what is shear force and bending moment, but may not be thoroughly. Otherwise you might have not given concentration or not shown interest towards to those all discussions. But now it is required for the GATE examination, for attempting the GATE examination. Very good aspirant and great aspirant, being as a great competitor, then you should have concept. Okay, so that I can tell you always. So all the best. Do prepare well, every one of you, and do come and join in the next week. Thank you one and all.
Thank you, sir.
Thank you. Okay, I am leaving the meeting, Andy.